Welcome and thank you for joining. We'll continue with another textbook question on page 75, number 17, and it seems like a thinking question. So let's read it first. If f of a equals 0 and f prime a equals 6, we have to find the limit as h approaches 0 of f of a plus h divided by 2h. So we'll focus on what we have to determine first. So we are trying to find the value of the limit as h approaches 0 of f of a plus h divided by 2h. And if you take a look at it, you probably recognize that this looks very familiar. And when you think a little bit more about it, you probably recognize the famous first principles formula in it. So you see we have the first principles formula, which is the derivative of a function at x equals a, which measures, again, the slope of the tangent drawn at x equals a on the function f of x, equals the limit as h approaches 0, f of a plus h minus f of a over h. Now, as you can see here, we have f of a plus h. We have f of a plus h in the first principles. We have h, and we have h in here. But we are missing f of a, and we have an extra 2 in here. So we're going to deal with them one at a time. But first, we are going to write the question itself. So the limit as h approaches 0 of f of a plus h divided by 2h. Now, recall the limit properties, very important here. So based on limit properties, if we have a constant in front of the expression inside the limit, this constant can come to the front. Let's say if we had a constant c, for example, so this constant can come to the front. And as you can see in here, we do have an extra number in this limit that we do not see in the first principles formula, and it's sitting right here. So I'm going to write that number slightly differently. So I'm going to write the number 2 in here as 1 over 2. That is multiplying f of a plus h divided by h. And we said that we can bring this constant to the front because we have the product of a constant with a change in quantity. So based on the value of h, which is getting close to 0. So this constant is not dependent on h, so it can come to the front. So we'll do just that. So that would be 1 over 2. Let's write our equal signs, nicely aligned. Limit as h approaches 0. And then inside the limit, we have f of a plus h divided by h. And now we're thinking, now what are we missing in here so that we can actually make this look exactly like this formula? So in order to make this look exactly like the derivative of a function, we're going to need to subtract an f of a. So we will do that. And as you can see now, we have the perfect first principles formula, which represent the derivative of the function at a. But we also know that subtracting a random number from an expression is not that cool because it changes the value of the expression, and we're not allowed to do that. So in order to fix this problem, we're going to subtract it. So in this way, we're going to add it, sorry. We're going to add it. So in this way, we have added the number 0. So if you look at it now, we have the first principles formula right here. That would be the derivative. But then we have f of a divided by h. So even if we were to split this, then we would be unable to. So now we're going to take another look at the information given and see how we can use this information in order to help us evaluate this. Now, as you can see, f of a here is equal to exactly 0. So what that means is that this is 0 and this is 0. So what that means is that we can replace the pink f of a by 0 very easily. And we can leave actually the blue f of a in here just for formality so that we can see that we are working here with some derivative. So let's continue writing this one more time. We have 1 over 2, and now the limit as h approaches 0 big fraction line, we have f of a plus h minus f of a divided by h. Now, we know that this is 0 and this is 0, but we are going to substitute this by 0 because then it will simplify the expression. But formally, we're going to need to write the f of a in here. Or we can look at this problem this way as well. So if we are at f of a plus h over h here, you can add very easily a number 0 or subtract a number 0, which is basically the same as subtracting the f of a, right? So, moving on, we have 1 over 2. And then the entire expression in here would be f prime of a. So we just found the simplified expression for the limit as h approaches 0, f of a plus h divided by 2h. And we will need now to evaluate the entire expression, but we're missing f prime of a. F prime of a is given to be 6. So we're going to say that would be equal to 1 over 2 and then times 6. And obviously this would be equal to simply 3. And we're going to say that the value of this limit is equal to 3. One more time. Thank you for learning with me, and I hope everything made sense and was helpful. Bye for now.